Okay. So we're going to look at normal contact force and motion in a vertical line. So we're still considering forces in one dimension, and we're still considering vertical forces now. Okay. So we've learned that we have this force due to gravity, which is a downward force on any object, right? And this force is basically just the weight times the acceleration. Okay, so if we remember to calculate force, it's just mass times acceleration. And if we wanted to calculate the weight, right, the force of you exert or gravity exerts downward on you, this is just the mass times the gravitational constant. So your weight is not really determined very much by the change in acceleration. Okay. Now we also learned that for an object to be at stationary or constant velocity, so if we want stationary or constant velocity, what can you tell me about the net force, Kiana, if you want stationary or constant velocity?
It has to be equal to 0.
Okay, we have to have a net force of 0, correct. Okay, so our net force must be equal to 0. Okay? There must be no force applying on you, or to remain at constant velocity. So that begs to answer the question that if we have an object, right, and this object is on a table, for instance, and this object has some weight, right? We know the weight of this object is its mass times the gravitational constant. If this object is sitting on the table stationary, right, we have to have a net force of 0, right? And at the moment, we don't have a net force of 0. We only have a downward force due to the weight. So there must be an opposite, equal and opposite force acting on this object, right? In the opposite direction, okay? So there must be some force acting in that direction. And those of you that do physics, well, you already know this force. Toya, do you know what this force is? Have you learned this before? Is this going to be something new for you?
I don't really remember this.
Okay, well, that's fine. That's fine, right? So this force that an object, this opposite force that's exerted on the object, right, is called the normal contact force. So this is the force that if you're standing up, that's the force that the ground is exerting on you. It's pushing up on you. Okay? If you have a coffee cup standing on a table, it's the force that the table is exerting on the coffee cup. Okay? So you're exerting a force downward on the table, and the table, or on the coffee cup, sorry, not you, unless you're standing on the table. Right? So the coffee cup is exerting a downward force onto the table because of its weight, and the table is exerting an equal and opposite force upwards onto the coffee cup, right? And that force is called the normal contact force. Okay? Right, Zara, tell me something interesting about this contact force. In what direction does it act?
It's perpendicular to the object.
Okay. Well, it's perpendicular to the surface that it's resting on.
To the surface of the object.
Yeah? So in my example, my little block on the table there, this is a nice example because this table is perfectly horizontal. So the force is perfectly vertical because this angle that it creates here is 90 degrees. Okay, that's really nice. Okay, if the table was at an angle, for instance, so if I had to put the table at an angle and I have the same block on it, right? the force would not be vertical anymore. The force would be out at an angle, all right? So it's always perpendicular to the surface, the contact force, okay? We're not going to be considering too many problems like this for now. We'll get to that. So for all the examples in today's situations, we'll just be looking at nice and simple ones. So we won't be looking at surfaces that are at an angle just yet. But it's important for you to remember that this contact force is always perpendicular. So we can actually write that because it's kind of important. So the contact force right? Just nice and simple. Everybody cool with that simple idea? Okay. If we consider net forces. Okay, remember right back in the beginning, we said that if you have a stationary object or one that's at constant velocity, it has to be, well, it has a net force of 0. Okay? All the forces cancel out. Okay, there might still be forces acting on the object, but they cancel each other out. And so that's what's happening with the weight of an object on something. The object is exerting a force onto the object, and whatever it's resting on must be exerting exactly the same force in the opposite direction for it to be stationary. So I'm going to give you a silly example just to explain this, all right? If we consider this as a table, right? So this thing that I've drawn here is a table. The weight of the object exerts a force onto the table, and so the table must be able to exert a force on the object on the way up, all right? But if the object in question or the table in question cannot sustain that amount of force, right? What will happen, Dominic?
The table will break?
The table will break, right? There will be acceleration because the table cannot provide enough contact force to sustain the weight of the object, and so the table will break and the object will accelerate down, okay? Okay, let's go and fetch today's example, nice and easy one. So here we have a lovely little crane, and it's lifting pallets, right? And on the pallets, we have stone blocks. Well, we have a stone block in the first one, okay? And its mass is 5 kilograms. The motion is vertically upwards. The crane lifts the pallet from rest to a speed of 3 meters per second in 6 meters, right? We want to find the contact force of the stone block during the acceleration. Okay, so what force is being exerted by the pallet? Okay, so as always, we need to go and draw ourselves a little diagram. Right, so I'm going to be lazy and I'm going to steal this one over here. Is that okay if I steal this one? So here we have our diagram. Obviously, you don't have to draw it as fancy in the test, just draw as rudimentary as you can. Okay, we know that the contact force must be perpendicular, so I'm going to leave that out. What key piece of information have I not identified yet, Raya? I need to write there's one more piece of information that I need to show on my diagram that I haven't done. Kind of like the most fundamental thing when we're talking about vectors. We always have to specify something.
The speed.
Okay, the direction of our acceleration.
Okay.
Okay, we have to specify in which direction we are considering positive acceleration. Okay, so I'm going to say that I'm considering everything up to be positive. Right, the weight of my stone block is 5 kilograms, so that's 5 times the gravitational constant newtons. So I can replace that with 5. Right, this is 5g newtons, and we know g is roughly 10, so it will be, if you really want, this is just going to be 50 newtons. And the force I'm trying to find is the contact force between the pallet and the stone block, right? So what force is the pallet exerting upwards onto the stone block? And I will call this force Q, right? I lie, I'll call this force R, because then we can call it a reaction force. Now it's just a matter of listing all the information that I have, right? I can't find the resistance force yet because I don't know the acceleration. So I'm going to just write down every single time all the information that I have. I know the initial velocity is 0 because it starts from rest. They tell me that the final velocity is 3 meters per second. And they tell me that this happens in 6 meters, right? And because it's 6 meters up, we're starting at 0, we're calling ground 0, and we're going up 6 meters. So there's been a positive change in displacement. So it's positive 6 meters. Right, and I want to find the acceleration, right, in one go. So the equation that I'll use to do that is this guy here. Now, I'm sure you've noticed that this equation gets used quite a lot, right? From here, it's just a matter of substituting in the information that we have. So we know the final velocity, we know the initial velocity. We're trying to solve the acceleration, and we know the displacement. This is going to give me an acceleration of 0.75 meters per second. And I'm going to stop, I'm going to think, right, my acceleration is measured up, the object is going up, it's accelerating on the way up, and so I've got the correct answer, right? If I got a negative 0.75, then I need to scratch my head and just think, did I do that correctly? Okay. Now that I have the acceleration, I can work out the forces, all right? And we're just going to use force is equal to mass times acceleration. This over here is the net force, it's the combined force. So when we are looking at net forces, we add the components together, we add the vertical components together. Okay, so the force pushing up is in the direction of acceleration, so it is a positive force, and the force of the weight of the object pushing down is negative because it's actually happening in the opposite direction of gravity, and so we have minus 50. Right, the mass of the object is 5 kilograms, and the acceleration is what we worked out as 0.75. And if we solve for r, we're going to move 50 over to the other side. We're going to get 53.75 newtons. So there's an upward force of the pallet on the way up. The pallet is pushing against the stone blocks at 53.75 newtons. Right, question B says, if the contact force exceeds 650 newtons, the pallets will break. Assuming the same acceleration as in part A, find out how many stone blocks can the crane lift safely. Okay? So this is like the table example I used. Sometimes an object can only withstand it can only push back a certain amount of force before it might break. So we can use, they've said we can use the same acceleration from the previous question. So we don't need to go and work out the acceleration again. We know the acceleration is equal to 0.75 meters per second squared. And what we want to see, or what we are saying, is that this resistance force, right, this reaction force from the down or the upward force from the pallet up, it cannot exceed 650 newtons. And quite simply, and the mathematical way of writing that is R must be less than 650 newtons. Okay. If the contact force is greater than 650 newtons, then the pallet will break, right? It cannot exert more than 650 newtons upwards. So we'll state again, force is just mass times acceleration. We need to reconsider the mass of the object, right? The mass of the object is not 5, right? It's going to be 5 times however many blocks we have. So if we have a variable that we can't solve for, we just use a letter of the alphabet to take its place, right? So 1 block weighs 5 kilograms. Right, so this is the mass that we're busy working out here. 1 block weighs 5 kilograms. And I don't know how many blocks there are that can go on the pallet yet. So I'm going to give it a variable and I'm going to say 5x. I don't yet know how many blocks can go on, but I know that each block weighs 5 kilograms. So the total weight of this object will be 5 times however many blocks there are. Right, my force is going to be a sum of all my forces. Right? So my reaction force is going to be 5, or still just R, right? Take away the force of, or the weight, the downward force from the weight of the blocks, right? Now we don't know the weight of the blocks, right? The weight of the blocks is 5 times the number of blocks times the gravitational constant. So 5x is the weight of the blocks. Sorry, not the weight, the mass of the blocks. And to work out its force, we multiply by the gravitational constant, which we're obviously going to substitute for 10 in a second. The mass of the object, well, we said that's 5 times however many objects there are, and we know the acceleration is that. So what we're going to do is we're just going to solve for R, and we're going to say R is equal to 5x 0.75. And when we move that thing to the other side, it becomes plus 5x times the gravitational constant. And now we're going to bring in the fact that this thing, whatever R is, must be less than 650 newtons, right? So if R must be less than 650 newtons and R is equal to that, that means that that thing over there must be less than 650 newtons. And so we can just write that as 5x 0.75 plus 5x times whatever gravity is must be less than 650 newtons. Okay. And here we're just going to solve for x. Okay, so I'm going to replace the gravitational constant with 10 and multiply 5 by 0.75. Anybody offhand know what 5 times 0.75 is? Currently it's 3.75. Oops, I've completely butchered. Okay, so we'll add the x's together and divide that number by 650, and so we'll get x must be less than 12.1. Okay, x is the number of blocks. So in order for the pallet not to break, they must be less than 12.1 blocks, except they didn't tell us we can chop little bits of the block up. So my final answer will be, well, there can be a maximum of 12 blocks. Super simple. Okay. Everybody happy with that? Nice and easy?
Yep.
Okay, so Toya, I think you're the only one that would have been in a little bit of the dark. And the other three, you guys are dealing with this in physics as well, right? So normal contact force, the force that the surface, not the object, the surface is exerting upwards on the object, right? The weight of the object is the force that the object exerts on the surface. Okay? And if they are stationary, they must be the same. If they are not stationary, they will obviously be different.